Hey everybody, thanks for joining me. Let's get started with number properties, which were invented hundreds of years ago by people just to drive you crazy. Okay, maybe that's not true. There is actual meaning to number properties, but it's hard to tell the meaning just by memorizing the property. So this isn't my favorite lesson in the world, but it is important because if you don't know the properties, you won't know the shortcuts. You won't know the reason why these things are happening, and then nothing your teacher says will actually make sense. So let's just get through this. We'll make it pretty quick. I've already typed up what I need to type up here, so I'll be able to just click on it and move on to the next one and not waste too much of your time. So let's get going here. We start with example number 1, which is the only example I see with a -1 in it. When you multiply a number by -1, it changes the sign. So -1 times a +5 becomes a -5. So that sounds a lot to me like the multiplication property of -1. There's nothing on this paper that even looks close, so let's just go with it. All right, now, in example number 2, you're changing the order. So 3 times 4 is the same as 4 times 3. That's true. It's the commutative property. When you commute to work, you're going from one place to another. You know, most people talk about that in terms of driving, their work commute. You're going from one place to another. That's what these numbers did. They went from one place to another. Another teacher that I just read the material of just a few days ago teaches their students that CO would be the first 2 letters of commutative, and change order is abbreviated CO. So that was the cheesy thing that they chose. If your teacher does that, that was really witty. I never thought of that before. Good for them. Shout out to them. I don't know who it was. I should have given them credit, but I didn't. So we're just going to move on. All right. 8 times 1 is 8. So basically, we found the number that you could multiply 8 by to keep it at 8. The number didn't change. It stayed who it was. That sounds a lot to me like your identity. Your identity is who you are. We chose the number 1 to multiply 8 by so that it could stay 8. You want to stay who you are. So there you go. That's your 8 times 1 is 8. That's the identity property. If your initial number and your final number are the same, then the identity of the number didn't change. All right, example number 4. Now we have grouping symbols. A group, an association. Sports fans, I always use the NBA as an example because it's the National Basketball Association. It's a group of teams that get together and play by the same rules. And whenever we're talking about groups, we're talking about parentheses. So it makes pretty good sense that example 4 would be the associative property of multiplication. All right, example number 5. Once again, if you look, we have a number that stayed the same. It started as 7. It ended as 7. The identity of the number didn't change. The difference in this problem is that we used addition instead of multiplication. Instead of multiplying by 1, we added 0. Same property, different way of using it. Example number 6, 4 minus 9 equals 9 minus 4. That's not even true. Which makes sense because it said in the note one of these examples is not true. Find it. The commutative property works for addition. It works for multiplication. It does not work for subtraction. 4 minus 9 is -5. 9 minus 4 is +5. So the commutative property does not work in that situation, which means that statement is not true. All right, we go to example number 7. We have more grouping going on. So that looks to me like more associating the numbers together. You're allowed to group them however you want in the case of multiplication and also in the case of addition. So we'll go with that. If you look at example 8, looks like they're just changing order. That's all it is. Nothing special there. Changing order, CO. Once again, the commutative property. In this case, we used it for addition, which is fine. So examples 2 and 8 are both commutative, 1 used multiplication, 1 used addition. All right, last but not least, when you multiply a number by 0, you get 0. The trick that people use all the time to try and stump a kid when they're trying to go through their process, you have kids multiply a whole bunch of numbers together, and at the end you throw in 0. And what you end up getting is 0. All of that multiplication you did in the beginning was pointless. Haha, we tricked you. We're just really mean sometimes. I don't know what to tell you about teachers. We're just sort of mean sometimes. All right. Answer these without a calculator. Now, the reason this comes into play, the reason we practice the properties, is that when you group numbers differently, when you organize them differently, when you change the order around, it really helps. So, for instance, what if instead of taking the order that we had, we changed it and we put the 19 and the 1 next to each other and the 12 and the 8 next to each other? Well, 19 and 1 is 20, 12 and 8 is 20, and 20 plus 20 is 40. So when we group them differently, I shouldn't say group because we didn't use parentheses, but when we order them differently, it can help us change the way we approach the problem, and it is the main difference why some people can do a lot of math in their head and some people can't. It's all about the way they organize their thoughts. Let's try this with multiplication. If you do 2 times 17, a lot of you don't know what 2 times 17 is. It's 34, but even if you do know that, now you have to do 34 times 5. Total pain. What if we rearranged? What if we associated a little bit differently and put the 2 times 5 together, which is 10, and then multiply by 17? Well, now you could just do 10 times 17, which is 170. Big time saver. Something you can do in 5 seconds instead of something that you would have to get your calculator out for. And if you don't have a calculator, that would make it even more frustrating. Last example here. It looks to me like the 1 and the 999 would make 1,000, and this would make 1,000. So once again, here we are taking something that looks intimidating, and we're trying to turn it into something much better looking. So that's pretty much the goal. And that's why we do all these properties. It's so that we can find ways to make the rest of our math life easier. All right, I hope that helped you out as we get started here, and good luck the rest of the way.